At the beginning of this year, my fascination with microscopic life led me into the UCL chemistry building. There I captured microscopic images of tap water, rainwater, and samples from the Thames, revealing diverse bacterial forms. Utilizing scanning electron microscopy, SEM, I reconstructed these bacteria in 3D, providing a tangible foundation for my design explorations. Delving into computational biology, I explored neural cellular automata, NCA, a hybrid of traditional cellular automata and neural networks. In NCA, each cell in a grid updates its state based on the states of its neighbors, with the update rules governed by neural network. This setup allows for the emergence of complex patterns and behaviors from simple local interactions, mimicking biological growth, erosion processes, and regeneration processes. Inspired by Laszlo Moholy-Nagy's kinetic compositions, I returned to my bacterial footage, crafting animations in After Effects that captured their movement and rhythm. To introduce interactivity, I employed Touch Designer, using real-time camera input of my own movements to distort the bacterial visuals, merging human and microbial dynamics. Later on, I merged the NCA algorithm with Touch Designer's interactive features so that I could draw structures using my fingertip in Cinema 4D. Before our field trip, I compiled a comprehensive digital library of these bacterial forms, animations, and simulations, setting the stage for their integration into architectural design. The site is located in Berlin and reuses the Humboldtine Flag Tower bunker. The bunker is located in Berlin's Volkspark and was constructed between October 1941 and April 1942 as part of Hitler's directive to build massive anti-aircraft defenses following the RAF's 1940 bombing of Berlin. This tower complex consisted of a G tower housing heavy artillery and an L tower for fire control. With walls up to 2.5 meters thick and ceilings nearly 4 meters thick, these structures also served as air raid shelters for thousands of civilians during World War II. Post-war, demolition efforts were only partially successful, leaving the Humboldtine Tower partially intact. Today it stands as a historical monument and a sanctuary for urban wildlife, including bats, rabbits, and foxes. The hill behind the site is completely artificial, as many hills are in Berlin, and half of the bunker, which was demolished, now sits underneath the ground. An estimated 66,000 cubic meters of concrete is buried behind my site. Each floor shares the same layout, and each floor has a gross floor area of 3,100 square meters, which remains substantial. In preparation for my project, I collaborated with Berlin National History Archive and der Berliner Unterwelden to access historical drawings, photographs, and films of the tower. Environmental simulations were conducted to analyze sun paths, wind patterns, and potential moss growth, informing the integration of natural elements into the design. Attempting to apply my bacterial simulations directly onto the bunker's geometry using UV maps in Cinema 4D and thereby distorting the geometry proved less effective than anticipated. However, implementing the neural cellular automata algorithm began to organically erode the building's facade, introducing a dynamic transformation. Exploring massing strategies, I considered excavating the landscape and extending floors, but I recognized that the existing structure sufficiently accommodated the programmatic needs. Drawing inspiration from Eduardo Tresoldi's ethereal wire mesh structures and the MFO park in Zurich, I developed rule-based simulations where digital bacteria navigated the building based on programmatic zones, green for the seed archive, red for the data center, and blue for the public library. Agents followed specific rules, such as red agents avoiding green zones due to moisture sensitivity, mirroring real-world environmental considerations. This agent-based modeling informed the design of an external scaffolding shell, complementing the eroded facade and creating interstitial spaces conducive to moss and ivy growth, blending the digital and the organic. Further research into similar bunker conversions, such as the Hamburg Flag Tower Hotel, Bernard Petz's bunker studio, and the Boris collection in Berlin provided valuable insights into adaptive reuse strategies for such monumental structures. The Hamburg Flak Tower Hotel shares the identical bunker typology as my site. Originally constructed as a World War II flak tower, this structure has been transformed into a green oasis featuring a hotel, concert hall, and rooftop gardens. The integration of greenery and public spaces into the massive concrete structure inspired my approach to incorporating vegetation and communal areas into the design. I also looked at the hierarchy of vegetation used for this bunker and applied a similar approach. Artist Bernard Petz converted a World War II bunker into a combined studio and living space, preserving the historical essence while adapting it for modern use. Many of the methods he used to slice up the concrete walls and floors of his bunker later informed my construction process. Similar to his design, I introduced outdoor ponds on the topmost floor. In the office spaces below, the caustic reflections caused by the pond would shimmer across the office space. The Boris collection in Berlin is housed within a former air raid bunker, where the raw concrete interiors contrast with the modern art installations. The adaptive reuse of the bunker into a cultural venue highlighted the possibilities of recontextualizing historical spaces for new purposes, informing my strategy for integrating public functions within the existing structure. My proposal converts the Nazi military bunker into a data center, a seed archive, and a public library. The redesigned Humboldtine Flak Tower encompasses multiple functions across its levels. The basement houses mechanical systems supporting a tropical greenhouse, seed archive, data center, and office spaces above. The ground floor features a public library within a 6-meter high floor-to-ceiling space, integrating natural light through the eroded facade and scaffolding. There is also a tropical greenhouse at the center of the bunker. The data center spaces emit heat, which is recycled into this tropical greenhouse space. The second floor contains offices for seed archive staff and storage facilities. The third floor is dedicated to data center operations. The fourth floor is dedicated to data center operations and laboratory spaces for seed analysis. The fifth floor provides additional office spaces. The sixth floor, which is the rooftop, is transformed into a landscape public area with 2 ponds above the office spaces, creating reflective light patterns and enhancing the workspace ambience. The massive circular spaces are kept as bat habitats, as bats are a protected species in Germany. From the ground floor, people can look up to see the tower being inhabited by bats. Adapting the robust concrete structure involved 6 primary cutting techniques. The thermal lance was utilized for precise removal of heavily reinforced areas such as former gun mounts. Hand chiseling was used in delicate zones requiring meticulous preservation, including historical features such as graffiti and wildlife habitats. Diamond wire cutting was applied for creating large openings and vertical shafts, providing clean cuts through thick concrete. Concrete sawing was used for horizontal cuts to adjust floor levels and to install new staircases. Robotic milling was used for intricate facade modifications and sculpting interstitial spaces with precision. Hydraulic crunching was applied in the demolition of non-load-bearing walls, minimizing noise and dust. These methods ensured structural integrity while facilitating the transformation of the bunker into a functional public space. Now, here is my final animation. Thank you.